Hello everyone. Well, students, in the last class, I told you something about normality. And in that, I told you that although it's not there in the CBSE syllabus, but you should know normality, equivalent mass for the better understanding of physical chemistry and concentration expression. Well, in today's class, we'll be doing stoichiometry. I'll teach you what stoichiometry is. We'll be talking about the limiting reagent. We'll be predicting the amount of product formed by the help of limiting reagent. Well, stoichiometry is derived from two words, that is stoichion and metron. Stoichions are the number of moles which are written before a reaction, before the reactants in a reaction, and metrons means measurement of that. Now suppose I have a reaction like 2 moles of A reacts with B to give me a compound like A to B. If I have a look at this reaction is giving me some information. Like in terms of moles, I can say 2 moles of A is reacting with 1 mole of B to give me 2 moles of 1 mole of A to B. So here I am getting 1 mole of A to B. Likewise, in terms of their volume at standard temperature, means since the reaction is at STP, I can say 2 into 22.4 liters of A is reacting with 22.4 liters of B to give me 22.4 liters of A to B. Or I can say 2 into molar mass of A is reacting with molar mass of B to give me molar mass of A to B compound. So when through a chemical reaction, we come on these conclusions, we measure them and we conclude something, that is known as stoichiometry. In stoichiometry, we get the mass or the volume of reactant, and through that we predict how much product we will be getting. In this, I give you one example. Suppose I have a reaction like 2H2 plus O2 gives me 2 moles of H2O. Now this reaction again is giving information like the previous one, that 2 moles of hydrogen, they combine with 1 mole of oxygen to give me 2 moles of water. Now many times it happens that amount of reactants they are given to you and you have been asked the amount of product which is formed. Here in this case, we can say that 4 grams of hydrogen combines with 32 grams of oxygen to give me 2 into 18 grams of water, that is 36 grams of water. But what about if this equation is given in a different way? If a question is asked where I have been given 2 or 3 grams, say 3 grams of hydrogen is given to me, 20 grams of oxygen is given to me, and I have been asked how many grams of water I'll get. Well, in that case, the first thing which I had to do, I had to select the limiting reagent. I had to see which among these two reactants, that is hydrogen and oxygen, is in lesser quantity. The reactant which is in lesser quantity is known as limiting reagent. As soon the limiting reagent will get exhausted, the reaction will stop. The product will not form. It may happen that the other reactant is left there, but since the reactant which is in lesser quantity is exhausted, so the other reactant is not getting any reactant to react with and will not get converted to product. That means the amount of product obtained largely depends on the quantity of the limiting reagent. So the first task we have got in our hand is to determine the limiting reagent. Well, in this case, how we'll determine the limiting reagent? In that case, we are not supposed to see these weights which are given to you. Because if you have a look at these weights, you'll see that 3 grams of hydrogen is reacting with 20 grams of oxygen. And if you compare them, it may seem that hydrogen is in lesser quantity. So it may happen that you may conclude that hydrogen is the limiting reagent, but it is not like that. We have to use stoichiometry. What I can do, I could again through equation, as I have seen in the equation from here, I can write 32 grams of oxygen combines with 4 grams of hydrogen. Therefore, see, the weight I've got is 20 grams. 20 grams of oxygen will combine with 4 by 32 into 20 grams. That is 10, here you'll get 16, that is 5, here you'll get 8, 4 to 8, that means you are getting 5 by 2 grams of hydrogen. That comes out to be 2.5 grams of hydrogen. So 32 grams of oxygen combines with 4 grams of hydrogen. So 20 grams of oxygen will combine with 2.5 grams of hydrogen. But the hydrogen which is given to you is 3 grams. That means the hydrogen is in excess. For reacting with 20 grams of oxygen, you need 2.5 grams of hydrogen. But the hydrogen given to you is 3 grams. That means after all the reaction will get over, you will be left behind with 0.5 grams of hydrogen. That means hydrogen is not in lesser quantity. So it is not hydrogen that will get exhausted. In fact, it is oxygen that will get exhausted. So oxygen is the limiting reagent in this case. So we can say, therefore, oxygen is limiting reagent. Hence, a limiting reagent is the reagent that is in lesser quantity. As soon the limiting reagent will get exhausted, the reaction will stop. So the quantity of product formed or the amount of product formed largely depends on the quantity of the limiting reagent. Now once I come to know my limiting reagent, then I can easily predict the quantity of product formed. Because we know that the quantity of product formed depends on the quantity of the limiting reagent. So here in this case I can compare the quantity of water formed with oxygen. What I can say, if you look at this equation, from here you can see I can write 1 mole of O2 gives 2 moles of H2O, or I can say that is 32 grams of oxygen gives me 2 into 18 grams of water. Therefore, the mass of oxygen which I have got here is 20 grams. 20 grams of oxygen will give me 2 into 18 upon 32 into 20 grams of water. Now here in this case, it comes out to be 4, then you'll have 10, then you'll have 2, then you'll have 5. That is, you can write that comes out to be 17.5 grams. I'm extremely very sorry, it is not 17.5 gram. In fact, it is 27.5 gram. It is 27.5 gram. This is what you are getting. So this is the amount of water you will get. Again, the first thing which I did is that I calculated the limiting reagent, and through that limiting reagent I calculated the amount of water formed. See, my dear students, as far as this question is concerned, it's a random question which I gave you. Randomly, this thing, it came to my mind that this much amount of oxygen I should give you and this much amount of water I should give you. I'm sorry, this much amount of oxygen I should give you. And through those quantities, first I'll help you in calculating the limiting reagent. I gave you the amount in such a way that the substance which was actually looking in lesser quantity, like it was seeming in this equation that hydrogen is in lesser quantity because we were getting 3 grams. So we were thinking maybe it is the limiting reagent, but it is not the limiting reagent. I give you in that way. I modified this question. That's why it took a bit while solving the calculations in the last. I do not have this question anywhere. It was all of the random that I gave you this question and I solved it like the way you would have solved it. So in case you would have been solving this question, you might have took some time while doing calculations. So this is how we do it. First we calculate the limiting reagent. Through limiting reagent we calculate the quantity of the product form, that is water. So this is what we did. Now I am giving you one example which is there in your textbook. In that in-text problem is given to you and the equation in that is N2 plus 3H2 gives you 2NH3. Now the quantity of nitrogen which is given to you is 50 kilogram and the quantity of hydrogen that is given to you is 10 kilogram and you have been asked the amount of ammonia that will be formed. Again, the first thing which you have to do is you have to calculate the limiting reagent. From equation it is quite evident that 28 grams of nitrogen reacts with 6 gram of hydrogen to give you 2 into 17 grams of ammonia. Now what we'll do, we'll find out the limiting reagent. I'm writing 1 mole of nitrogen reacts with 3 moles of hydrogen, that is 28 grams of nitrogen reacts with 6 grams of hydrogen. Therefore, 50 kilogram of nitrogen will react with 6 by 28 into 50 kilogram of hydrogen. Well, students, here I would like to tell you one thing, that you need not to convert 50 kilogram into gram. When you were writing 28 gram of nitrogen is reacting with 6 gram of hydrogen. So after that a step comes where you write 1 gram of nitrogen reacts with 6 by 28 grams of hydrogen. In the numerator you have got 6 gram, in the denominator you have got 28 gram. So both grams, they will get cancelled and you will get a ratio, that is 6 by 28. So 6 by 28 is a ratio and it does not have any dimension. It will get the dimension with which you are multiplying on the reactant side. When you are writing therefore 50 kilogram of nitrogen, here you will multiply it by 50 kilograms, so the answer automatically will come in kilogram. You need not to convert kilogram into grams. So here in this case, you can solve it and you will get the limiting reagent. Like if I do this, if I do the calculation, that is 50 into 6, that comes out to be 300 and I divided by 28. So it comes out to be 10.71. That is 10.71 kilogram of hydrogen. That means 50 kilogram of nitrogen will need 10.71 kilogram of hydrogen to react. But the hydrogen in this question which is given to me is 10 kilogram. That means I need more hydrogen and the hydrogen given to me is in lesser quantity. So, therefore, hydrogen is the limiting reagent. Now, from both of them, nitrogen and hydrogen, I know that hydrogen is the limiting reagent. That means how much amount of ammonia will be formed, that will be related from hydrogen. although it can be related to nitrogen, but nitrogen is not the limiting reagent. The quantity of product which I'll get is very much depends on the quantity of the limiting reagent. By now I know that the limiting reagent is hydrogen, because to react with 50 kilogram of nitrogen, I need 10.71 kilogram of hydrogen, and the hydrogen which is given to me is 10 kilogram. That means lesser quantity of hydrogen is given to me. So I'll relate with the hydrogen the quantity of ammonia which is formed. So what I can say, I can write 3 moles of hydrogen gives me 2 moles of ammonia, which you can see in the equation. Here you have this equation. In this you can see that is 6 gram of hydrogen gives me 34 grams of ammonia. Well, the molar mass of ammonia is 17, so 17 into 2, that is 34 grams. Therefore, 10 kilogram of hydrogen will give me 34 by 6 into 10 kilogram of ammonia. So that basically becomes 340 by 6. It comes out to be 56.6. So the quantity of ammonia that is formed is 56.66 kilograms. This is how you can do it. This is how you can calculate the limiting reagent, and this is how you can predict the quantity of product formed. This is stoichiometry. This is all about limiting reagent. Next, we'll talk about the molecular and the empirical formula and how to calculate it. So we'll see molecular formula and empirical formula. In this, I would like to give you one example. Suppose I got a compound like C6H12O6. This is the molecular formula of glucose. So this is the molecular formula. But if I write the ratio of different elements, then it becomes CH2O. This is the empirical formula. So what is molecular formula? If you want to write down the definition, you can please write it down. Molecular formula is the formula which tells us the exact number of different atoms present in a molecule. So it tells you the exact number of different atoms which are present in the molecule. Whereas if we talk about empirical formula, it gives us simplest whole number ratio of different atoms present in a molecule. So the ratio of carbon, hydrogen and oxygen is 1 is to 2 is to 1. So that is empirical formula. Now what is the relation between empirical formula and molecular formula? We can say molecular formula is equal to N into empirical formula. Now the question comes to our mind, what is N? Well, N is any integer. It can be 1, 2, 3, 4, 5, any integer. It can never be 0 or fractional. Now the second question which comes to our mind, where from we can determine the value of N? Well, N is always equal to molar mass divided by empirical mass. I'll give you an example. Suppose when we were talking about this glucose, suppose I talk about this glucose molecule, the molecular mass of this glucose molecule is 180. Now if we talk about the empirical mass is 30, 12 for carbon, then 2 for hydrogen, that is 14, 14 plus 16 for oxygen, that comes out to be 30. If you divide 180 by 30, you will get a value of 6. That is, in this case, the value of N is 6. So if you multiply the empirical formula by 6, you will get the molecular formula. That is, if you multiply this empirical formula which is given to you here, you will get the above formula. that is C6H12O6. This is what you'll get. Now the question comes to our mind, how to calculate the empirical formula. Well, students, if it is asked that you have to calculate empirical formula, then you have to calculate the empirical formula. But if you have been asked to calculate the molecular formula, then also you have to calculate the empirical formula. First you will calculate the empirical formula, then you will multiply it by n, then only you will get molecular formula. So we'll see how to calculate the empirical formula. I tell you, for that you need to draw a table. The table will be roughly like this. It will be divided into some columns, like column number 1, column number 2, 3, 4, 5, 6 and 7. Roughly I am doing. It may happen that we will not need all these columns. Well, the first one is serial number. That basically tells you the number of atoms you have got. Suppose I am talking about glucose. I have got 3 elements. So 1, 2 and 3. The second one is the symbol of the element. That is carbon, hydrogen and oxygen. The third one is their atomic mass. Well, for carbon it is 12, for hydrogen it is 1, for oxygen it is 16. Then you will have percent. Percent will be given to you in the question. You will be told about a compound, like a compound is formed by the combination of carbon, hydrogen and oxygen. It contains X grams of carbon, it contains X percent of carbon, Y percent of hydrogen and Z percent of oxygen. So we can write percent here, that is X, Y and Z. After that we'll have relative number of atoms. Well, relative number of atoms is always percent divided by the atomic mass. So here in this case it is X by 12, here it is Y by 1 and here you have Z by 16. So it is actually percent divided by atomic mass. Now suppose the value which I am getting are A, B and C. We'll see which among them is the smallest one. Now randomly I am taking, suppose C is the smallest value. If C is smallest, then I will divide all the relative number of atoms by C so as to get simplest ratio. So the next one is simplest ratio. Well, in this case it is A by C, in the second one it is B by C, and in the third one it is C by C. Now supposedly I am getting some values like here I am getting 1, here I am getting 1.1, here I am getting something like 1.5. We can round them off to get simplest whole number ratio. So if I multiply all of them by 2, I will get 2.232. That comes out to be actually 232. In that case, I can say that the empirical formula is C2H3O2. So this will become the empirical formula. I give you this example randomly. So this is how we can calculate empirical formula. Once you will calculate empirical formula, you will multiply it by n and you will get the molecular formula. So this is how you can do it. I'll give you one example for this. Well, a question is given in your textbook where it has been stated that there is a welding fuel gas. I tell you the molecular formula of welding fuel gas, that is actually acetylene. So its molecular formula is C2H2. And as you can see, you can predict its empirical formula is CH. It has been told that a welding fuel gas is there which is made up of carbon and hydrogen only. And if you burn a small sample of that, you'll get water that is 0.2 0.690 grams. Well, this is what I can remember. I do not know the question exactly. This is what I can remember. You kindly check that the value in the textbook also. But you will get an idea how to do this question. And CO2 is given to you 3.34 gram. This is what I can remember. After that, it has been told that 10 liters of gas at STP weighs 11.4 grams. And what you have to do? You have to calculate the empirical formula. You have to calculate the molecular formula. And you have to calculate the molar mass also. Now the question comes to our mind how to do this. First in this you have to use some stochiometry. You don't know how much mass of that gas you have burned. But one thing is for sure that that gas is made up of carbon and hydrogen only. So whatever hydrogen you are getting in water is from that compound, and whatever carbon you are getting in carbon dioxide is also from that compound. So first we'll calculate the amount of that carbon and hydrogen. So for that what I am writing, 1 mole of water contains 2 moles of hydrogen. That is 18 gram of water contains 2 grams of hydrogen. Therefore, the quantity of water which I get 0.690 gram of water contains 2 by 18 into 0.690 grams of hydrogen. Well, in this case, 0.690 multiplied by 2, that comes out to be 1.38, and if I divide it by 18, it comes out to be 0.766 grams of hydrogen. So this is the mass of hydrogen which I have got in 0.690 grams of water. So 0.690 grams of water which I am getting by burning that small sample of welding fuel gas actually contains 0.0766 grams of hydrogen. So this is the mass of hydrogen I have got. Likewise, I'll calculate the mass of carbon dioxide. I can say 1 mole of CO2 contains 1 mole of carbon. That means 44 grams of CO2 contains 12 grams of carbon. Therefore, well, the amount of CO2 which I got is 3.34. This is what I can remember. Kindly check that in your textbook. Therefore, 3.34 grams of CO2 contains 12 upon 44 into 3.34 grams of carbon. Well, in that case, 3.34 into 12, that comes out to be 40.08, and if I divide it by 44, the value comes out to be 91.09. That is 91.09 grams of carbon. My dear student, here I would like to tell you one thing, that the compound, as it is given in the textbook, the compound is made up of carbon and hydrogen only. And that the small sample which I burnt contains 0.0766 grams of hydrogen and 91.09 grams of carbon. Nothing else. That means the amount which I burnt is actually 91.09 plus 0.766. So plus 0.0766. That comes out to be 98. So the amount So the weight of gas burnt is 98.987 grams. Because that gas is made up of carbon and hydrogen only, the carbon in that is 91.09 grams, and the hydrogen in that is 0.0766 grams. Now we have to calculate percent. I can say percent of hydrogen. Well, percent is always the weight upon total mass into 100. That is 0.0766 divided by 0.98 into 100. In that case, it is 0.0766 into 100, which comes out to be 7.66 divided by 0.98, and it comes out to be 7.81 grams. That means the percent of hydrogen is 7.81 grams. Likewise, we'll calculate the percent of carbon. That is 91.09 divided by 98 into 100. So it is 91.09 into 100. That is 9109 divided by 98, and it is 92. So here in this case it is 92.94. That is roughly 93. Now by now we have got the percent of carbon and hydrogen. We can use this data in the same table which I taught you for empirical formula. So again, in that table, I'm marking the same columns. That is column number 1, and you have 2, 3, 4, 5, 6 and 7. Serial number, that is 1 and 2. Symbol of element, that is carbon and hydrogen. Atomic mass of element, that is 12 and 1. Percent, which we have already calculated. So for carbon, it is 93 almost. So we can write it 93%. And for hydrogen, we can write it 7%. If you want to write it down accurately, you can do that. But later on also, we have to round it off. If you want to write it, it's 7.81. If you want to write it down like 8, you can write it. But you know that the sum of percent can never exceed 100. So what I am doing, if I am rounding it off to 93, I am writing the other one as 7. If you want, we can, I'm writing it 93. The other one, I am writing, say, 7.81 as it was, as we calculated it. I'm writing the same thing. So after that, we'll get relative number of atoms. Relative number of atoms, I told you, that is always percent divided by atomic mass. So here also it is 7.81 divided by 1. It will come out to be 7.81. Well, as for 93 is concerned, 93 when divided by 12 gives you value 7.75. So 7.75. You can say that 7.75 is the lowest value. It is the lower one among these two. So we'll get simplest ratio. And in that I told you that you have to divide both the relative number of atoms by the one which is lesser in quantity. So I'll write 7.75 divided by 7.75. Here in this case, I'll write 7.81 divided by 7.75. You know, in both of them, it is nearly equal to 1. So the simplest ratio is 1 and simplest whole number ratio again is 1. That means the empirical formula of the compound is C1H1 and its empirical mass is 13. Now, to calculate molecular mass, we need to calculate molecular formula, we need to calculate the molar mass. We again will have a look at the question. Well, according to the question, 10 liters of the gas weighs 11.4 grams. I'll use Avogadro's law, which I taught you earlier in the last class. I taught you that. So I can say 10 liters of gas at STP weighs 11.4 grams. Therefore, 22.4 liter of gas at STP will weigh 11.4 divided by 10 into 22.4. So that is 22.4 into 1.14. Well, it comes out to be 25.53. 25.53 is the molar mass which I am getting. So, in order to calculate the value of N, I told you that it is always molar mass divided by empirical mass. Here in this case, it is 25.53 divided by 13. So, if I divide it by 13, it comes out to be 1.96. And we know that N is an integer, it can never be fractional. If it is coming out to be 1.93, I'll round it off, that means it is nearly equal to 2. If I multiply the empirical formula by 2, I will get C2H2. So this is the molecular formula of the compound. So the molecular formula of the compound is C2H2, its empirical formula is CH, and its molar mass is 25.53. So this is how we can do empirical and molecular formula. I hope you might have got this. And this is what we should do, means we were supposed to do in this class. Rest of the topics, as far as concerned, you'll we have done all the topics like concentration expression, including the normality. Some of the topics like average atomic mass, these type of topics we have already done, and they'll be coming in the next chapters also. Some of the chapters like when we'll be talking about the atomic mass and structure of atom, we'll be doing them. It's very easy actually. Average atomic mass, whenever we have to calculate it, we'll multiply the percent which is given to us with the atomic mass of that particular isotope. And we have to add all these percent multiplied by their atomic mass. And then we have to divide it by 100. And we'll get average atomic mass. For example, chlorine, it exists in two isotopic forms, that is 35 and 37. Suppose the percent of 35 is X and the percent of 37 is Y. So what I have to do, 35 into X plus 37 into Y divided by 100 will give me the average atomic mass, and that is actually 35.5 for chlorine. So this is how we can calculate the average atomic mass. And this is all about this chapter. With this, your mole concept chapter is over. I'll give you a small class on this, one more lecture, and that lecture will be basically involving some of the introduction of significant numbers, dimensional analysis, and this average atomic mass. That will be a very easy type of topics. So we'll be doing them in the next lecture. So this is all what we were supposed to do in this class. Again, students, I request you one thing. Please do subscribe my channel and please do not forget to press the bell icon, because then only you will be getting all the notifications. So as I am uploading more and more videos, you should be aware of all these videos. Kindly do subscribe this channel and kindly do press the bell icon. Thank you very much. Thanks a lot for joining. Thank you.